Hi there, welcome back to the fourth video in Let's Figure AWS VPC series. Now in today's video we would be talking about how to provide an internet connection to our resources, to our virtual machines that we have created in our VPC and in our subnets. So before we move on, let's have a quick recap of what we have covered so far in previous videos. So we said in AWS we can protect our resources by creating our own virtual boundary called as VPC. VPC is created in a region, it has a name and a set of private IP addresses. Now, a VPC is further subdivided into smaller areas called as subnet. Again, subnet has a name, a list of private IPs which would be used for assignment of virtual machine IPs, plus subnets are created in an availability zone. Then in part 3 we saw that how virtual machines created in our subnet are protected. We said that the virtual machines are protected by a security component called as security group, in which we set two types of rules, inbound rules and outbound rules, which control the kind of traffic that will be flowing into our virtual machines and the traffic that will be flowing out. Likewise, at a subnet level, there is one more security component called as network ACL. Again, network ACL has a set of inbound rules and outbound rules that control the traffic flowing in and out of the subnet. So this is where we were till our previous video. Now today we will be talking about how to provide internet connectivity to our resources, to our virtual machines created in a VPC and in a subnet. So imagine a case where you have your web server and your web server needs to connect to an external server. Example, maybe this web server is an e-commerce application and you need to connect to an external payment gateway or to charge your customer's credit card. Now in this case, in your code, if you just provide the IP address of the payment gateway or the domain of the payment gateway, will the things work? The answer is no. Any reason why? If you have followed the third video, you already know the answer. Yes, that's right. So the first thing for our traffic to flow out is we need to configure the appropriate rules. All right. So now in this case, what we need to do is we need to configure rules at the security group level saying that allow an outbound HTTP connection. And likewise, an inbound response for HTTP response rule will be automatically created because security groups are stateful. Next, we'll have to configure an outbound HTTP rule in our network ACL, allowing the HTTP request to pass through. And likewise, we'll have to configure an inbound rule to allow the HTTP response. Now, just by doing this, will our virtual machine, will our web server be able to connect to the external server? The answer is still no. Now, why is that? So what have we discussed till yesterday? That by creating appropriate rules, our request will reach the router or router, whichever way you want to call it. Now, once it has reached the router, what would the router do with it? Remember what we said yesterday. Router just handles the traffic within the subnet and within the VPC, to be specific, right? In fact, VPC is such an isolated network that it doesn't have an internet connection at all. So imagine a case where you connect 4 or 5 computers in your home, right? With a LAN cable. All those computers are in a network. Does that mean those computers achieve internet connectivity? No, you need to then explicitly provide an internet connection to your network. Likewise, VPC is a completely isolated network, completely isolated area, such that by default, VPC doesn't even have an internet connection. So there is no way that your request will cross the VPC and reach out to some other server on the internet. So that means you need to provide an internet connection to your VPC. Now don't worry, that does not mean you need to sign a contract with a broadband provider or something like that. You are in AWS. All you need to do is you need to create one more component called as Internet Gateway. Pretty simple to create. Just right click, say create an Internet Gateway. And once you create this Internet Gateway, all you have to do is you have to attach that Internet Gateway to the VPC. Once you do that, your VPC will now have internet connectivity to the outside world, which means once a request reaches the Internet Gateway, that Internet Gateway can then forward the request to other publicly available servers. So think of an internet. So yesterday we said, think of router as an internal courier service, right? An internal facilities guy which will carry your parcel from one department to another. Likewise, think of Internet Gateway as an external courier service, right? An international courier service which will take your company's parcel and which will actually deliver it to a different city, same city, different country, whatever, wherever that parcel is destined to, right? So let me come back. What is the use case we are talking about? We are saying our web servers want to connect to some external servers, maybe a payment gateway on the internet. And for that, once you have configured the appropriate rules in your security group and network ACLs, first thing you need to do is you need to create a component called as Internet Gateway and attach it to your VPC. This will give internet connectivity to your VPC. Now, once you have done that, do you think your HTTP request will now pass through and will reach the external web server? The answer is still no. Something is missing, right? See, in this whole diagram, your request will pass through, it will come to the router. Now, how would the router know that this request needs to be given to the Internet Gateway? Your request has to reach to the Internet Gateway. Your parcel is with your internal, internal courier service guy. Now he needs to know that your parcel has to be handed over to an external courier service so that that service can then deliver it to whatever destination it is. Now, how do you do that? Now, for that, you need to tell your router or your router that, hey, requests from my subnet, some of these requests you have to forward it to Internet Gateway. How do you do that? You do a configuration to your router, the router that is created. And all you have to do in that configuration is you have to say, if the traffic is directed to a IP address, please forward that traffic to Internet Gateway. That's all, because all the traffic will be received by the router. And you will say, if you receive any traffic, please forward that traffic to Internet Gateway. So here the configuration that you would do is 0.0.0.d0/0. That means any IP address on the internet, right? What will you say? Please forward it to Internet Gateway. Now, once you have created this configuration file, the next thing that you need to do is you need to associate that configuration file to your subnet. So think of this as maybe to that internal courier service guy, you are handling a sheet of instructions where you say that, hey, if you receive parcels from my department, please do this. If the parcel is destined for these particular addresses, send it to the Internet Gateway, right? So you need to associate that set of instructions to your subnet so that the router knows that, hey, if the request comes from this particular subnet, I need to apply these instructions. Now, once you do that, and once the router receives traffic from SN Web, what will happen? The router now knows what it's supposed to be done. It will take that traffic and it will forward it to Internet Gateway. And then the Internet Gateway will do the needful. It will then forward the traffic to the outside world, whichever server it is destined to. Got it? So basically create an Internet Gateway and then configure your router with certain configurations which will tell the router to forward that traffic to Internet Gateway, and then associate your subnet to that router configurations so that the router knows that, hey, this configuration is with this subnet and I need to apply these instructions. Now, as per what we have discussed so far, you would say, hey, if I give the configuration 0.0.0.0/0, that means even if there is a traffic that is destined to maybe another virtual machine within the VPC, let's say 10.0.2.10, maybe a traffic is destined to your another database server, right? But as per this instruction, what will happen? Even that traffic, the router will forward it to the internet gateway. You don't want that to happen, right? Internal traffic, you want that to be forwarded to internal servers, and only external traffic should be forwarded to internet gateway. In fact, this scenario will never happen. That's because when you create a configuration for the router, that configuration will already have one implicit setting, which will say if there is any traffic within the IP range, and this is the CIDR of your VPC, within the IP range 10.0.0.0/16, then that traffic should be taken care locally, right? So this you don't have to configure, this is always there. What you do is you provide one more set of instructions saying that if there is any other traffic which does not fall in this range, any other traffic, then please forward that traffic to the internet gateway. And in this way, the router knows which traffic should be forwarded to servers within the VPC and which traffic should be forwarded to the servers outside the VPC by forwarding that traffic to internet gateway. All right, good. So now let's go ahead. In fact, every subnet, right? The traffic from the subnet reaches the router. Every subnet is actually associated with this configuration file. All right. So even the SNDB that we had created yesterday is associated with a configuration file. And that configuration file, as I said, every configuration file has this default value. Any internal IP address, please try to send it, or at least try to forward it locally. So both the subnets yesterday that we created were associated with configuration file, and what we'll have to do is we'll have to create one more configuration in which we'll provide the details of internet gateway. This configuration file that I was talking about, this is just a lame term so that people understand it appropriately. This is called as a route table. So every router that is already there in your VPC can have multiple route tables with it. And what is route table? Think of it as an itinerary which has multiple routes in it, right? So there is one default route table always created, which is called as main route table, and you can create additional route tables also, which will give instructions to the router what should be done with the incoming traffic. And that route table has to be associated with the subnet so that the router knows when the traffic is received from a particular subnet, which routes should be assigned. So this configuration is called as a route table, and route table has nothing but a collection of routes, right? And a route is very simple. It just has two things in it: a destination and a target. Example, if my destination is any IP address for Hotmail, Gmail, Yahoo or whatever, please forward that request to internet gateway. If the traffic that you receive has a destination of maybe 10.0.2, which is my database, then please forward that traffic to an internal server, right? So that is what is called as a route table, the configuration for your routers. All right. So let's move on now. So just now we discussed about the scenario as to what all you need to do to maybe make your web server connect to a server external to the VPC. Now in today's demo, we'll do a little different scenario. So again, we are back to yesterday's or part 3's scenario where we have created VPC and we have two subnets with network ACLs and stuff. Now recall that this is a web server. So web server means we want people from outside world to connect to our website, send an HTTP traffic. So again, don't get confused. We are explaining the same concept of internet gateway, but through a different route. That was previously we talked about from bottom to top. Now we are talking about top to bottom. Now here we are saying that if you have a web server, how would the request from outside world reach the web server? So again, same things, right? So this I'm showing a user from outside world needs to connect to the web server. What do we need to do? First, we need to configure or create an internet gateway that should be attached to your VPC. Once you do that, the request from your external users will reach your internet gateway. That means will reach till the gates of your VPC. Next, you need to create a route table for your router, and in this route table, and once you create a route table, it will always have one default route which will tell the router how to handle internal traffic. And in this route table, you will create one more route explicitly where you will say any incoming traffic from outside world 0.0.0.0, please pick it up from internet gateway. So with this, the router knows that once it has received the traffic, and you need to attach this router to your subnet. Once you do that, the router now knows that any traffic that is received from the internet gateway, it now needs to forward it to your SN web, subnet of your web servers. Next, what you'll have to do, you'll have to create appropriate inbound rule for your network ACL and your appropriate outbound rule explicitly for your network ACL to allow incoming request and outgoing response. Likewise, you'll have to explicitly create an inbound rule in your security group to allow incoming HTTP request, and the outbound request will be automatically allowed since security groups are stateful. All right. So this is what we'll be doing in today's demo. For that, stay tuned. Let's first log into the management console. Okay. So let's have a demo on internet gateways. I am logged into management console. I will right click and go to my EC2 console. Basically, we are going to the VM web that we had created yesterday. And the first thing that we'll do is, this is the VM web that we had created yesterday. Now this VM web has a public IP of 54.254 whatever. So I'll just copy it as is without doing any additional things. We'll try to access it directly from my web browser and verify whether all the things that I said in the session was true or I was just bluffing. Do we really have internet connection or not? By default, as I said, we will not have. So let's wait and see. All right. So by default, if you try to access your web server, it will not be accessible from outside world. So we need to do configurations. The first thing that we'll do is we'll configure the rules for security group and network ACL. So for that, right click, I'll go in the VPC management console, go to your VPCs from the navigation pane. VPC HR is the one that we had created yesterday. We will go first in security. We'll go to network ACLs and we'll configure the rule for network ACLs. NACL SN web is something that we created yesterday. I select on it. We need to configure inbound rules and outbound rules. So I'll first configure inbound rule, click edit inbound rule. Yesterday we had created this rule to receive responses. Now I will add a rule. This time I'll say rule number 100 and we'll say allow HTTP traffic. So sorry, over here in type, we'll say HTTP on port 80 from any IP address. I will click save. Next, we need to configure outbound rule. to allow the response from our web servers to pass through. So for that, I'll click edit. I'll say add a rule. Again, responses will be on high value port. So typically I keep that rule at the maximum, at a higher rule number 999. And here I'll say port range 1024.655.35. We don't know on which client port will our web server give the response back, because it is the client request which says that, hey, give me response back on a particular port. So I open this whole bunch of ports and I click save. We have configured network ACL. Let's go ahead and configure the security group. So left hand side navigation pane, I click on security group. SG web is something that we created yesterday and is attached to our VM web. Again, in inbound rules this time, I will click edit rules. I'll click add rule, and in type again I'll say in the security group allow HTTP request to pass through on port 80 from any source IP. That's fine. And I click save. Say close. No need to configure any outbound rules to allow the responses. Why? Because security group is stateful. I have repeated it so many times. You should be able to answer this question even in your dreams. Okay, so having done that, our security groups and network ACLs are configured. Let's check whether we can access the web server. I click a refresh. We got an error saying that the web server is not accessible. So what do we do next? Next, we know that the VPC does not have an internet connection at all. So let's give it an internet connection to the VPC. How do we do that? Left hand side in the navigation pane, we go to Internet Gateways, click on it. Here I already have one Internet Gateway which is attached to my default VPC. I'll go ahead and create a new Internet Gateway and I'll give it a name IGW attached to VPC HR. I click create. I say close. My internet gateway is created, as simple as that. That's all. Nothing else you need to do. But notice that state, it says detached. So you need to attach an internet gateway to a VPC. Very simple. Again, select the internet gateway in the console, go in actions and say attach to VPC. Here in the drop down, select the VPC HR that we had created and I click attach. Alright, so with this, internet connectivity has reached our VPC. Let's test it again. Let's see whether now the web server is accessible. I go back here and I do a reload. We got an error again. That means the web server is still not accessible in spite of internet gateway being attached to VPC. What is the reason? Remember the diagram? We said the internet has reached your VPC gates, but it still needs to reach your router. And the way you instruct your router is by creating route tables, right? So we create route tables. Left hand side in the navigation pane, we have route tables. We click on it. Notice that here I have two route tables whose name is RTmain, RTmain. One says, this is the route table attached to my VPC default. There is also an RTmain attached to a VPC HR that we created yesterday. How come? So we did not create this route table. This route table was automatically created whenever you create a VPC. So every time you create a new VPC, in that VPC, a route table is created by default, one route table, which is conceptually called as a main route table. And all the subnets that you create gets implicitly associated to that main route table. So if you notice, if I go to SN web that we created yesterday, if I go to route table, notice that SN web is already associated to RTmain. Likewise, if I go to SNDB, notice that even SNDB is implicitly associated to RTmain. Now, if we wish, what we can do is we can make changes to RTmain to say that send the traffic to Internet Gateway. But if we do that, what will happen? It will give internet connectivity to both the subnets. We don't want to do that, right? So instead of making changes to your RT main, which will affect both the subnets, what we'll do is we'll create a new route table and we'll attach that route table explicitly to our SN web. Creating a route table is simple. All we do is click over here, create route table, name I will say RT, I'll call it RT public because it's going to give internet connectivity, and this basically in VPC HR, so that from the name itself we could figure out that this route table is in which VPC. And I say create, I say close. Fine, RT public is created. Now we need to associate this route table first to our subnet. So I select this route table. In the subnet association tab below, notice that currently this route table is not associated to any subnets, right? So this is a route table for the router which gives certain configurations. And what is the default configuration? Remember, we discussed about it. This allows the internal traffic to flow from one virtual machine to another because of this one route, which is the default route, which cannot be deleted or edited. You can add additional routes, as we'll do in just a moment. But first, let's associate this route table to our subnet. So I go in subnet association, I click edit subnets association, and here I will select SN and I click save. All right. So now I have two subnets, SNDB and SNWeb, and each subnet is associated to a different route table. SNWeb is associated to RT public, SNDB is associated to RT main. Now let's go to RT public, and if you could recall, we need to add the routes in RT public. Now this one default route allows inter VPC connectivity. Next we'll do edit routes. And I'll say add a route. This time I'll say if IP addresses are within 10.0, then take it locally. Otherwise what? Otherwise I'll say any other IP addresses 0.0.0.0/0. Any other IP addresses, send it to which target? Not local, instead send it to an internet gateway. The moment I selected, it is asking which particular internet gateway. I'll select the internet gateway that we have created. Internet Gateway VPC HR, and I click save routes. I say close. So with this, all our configuration is over. Now let's go back and see whether we can access the web server. If I do a reload this time, there you see, I can now access the web server. That means from my laptop, I can send an HTTP request to the web server running in an AWS VPC. All right. So from the demo, I hope it is clear how do we basically give internet connectivity to our resources created in a VPC and in a subnet by creating internet gateway and then configuring appropriate routes in a route table that is attached to our subnets. So this will give both inbound and outbound connection to our resources, to our web servers. Now, in our next video, we will be then focusing on resources within our SNDB, within our private subnet. So coming back, so this subnet that we created where we have given internet connectivity, conceptually that subnet is called as a public subnet. Why? Because resources in that subnet can now be reached out over internet. Now compared to that, if you look at the other subnet that we created, SNDB, that is called as a private subnet because resources in your private subnet does not have internet access. Now in next videos, we will still see even if you have resources in your private subnets, How can you connect to those resources? How can you connect to your databases? Maybe establish an RDP connection to do configuration of your databases by creating something called as Apache servers. And in future videos, we'll also see how do we give outbound internet connection to our databases so that our database servers can apply latest security patches, latest updates by using a component called as NAT. Having said that, thank you very much for watching. Don't forget to subscribe to the YouTube channel and stay safe. Bye bye guys.